All right, so welcome back. Welcome back to the channel. So over the last few videos, we have been learning a lot about language modeling. We have spent some time on how language models work. We have been using some language models and some more. So in this video, I just want to bring a paper to your notice that I found really influential and pretty good and pretty problem solving. And I think this is the first time for me to look at a paper that is solving this problem. I think previously I haven't personally seen any model like this. So I'll just open this communicative agents for software development. So as the name suggests, we are going to automate software development. Uh, yes. So the model actually, I just open this, right? Communicative agents for software development. So the idea is, so we are going to automate the the complete process of software development. So we're going to have like software development, right? We have did this like the software development involves many functions and many parts that should be worked on. So what we are going to do is we are going to create an organized set of language models and organized set of AI. Each AI agent, we're going to call each person here. Person refers to AI here because we are automating everything, right? So we are going to have language models and agents, and these agents are going to be grouped up in teams, and these teams are uh, organized and managed by a model called chat dev that we are going to build, right? So for example, given a problem, whatever problem you have, you'll be having a designing team. A team, we are going to have a team which will design our application or our software, whatever that is, an interface, how the interface looks like, the thing and all that. And we're going to have a coding team, we're going to have the testing team and documenting team. So these four fields, or see, these four tasks are considered here. So these are the main four tasks that are involved in software development, of course. So therefore, we're going to have this task, and we're going to have a nice connection between these and using a language model. And I think this is probably the first model that I have seen. And I think I think there are I think there are very less papers that are dealing with this problem, at least, which I find. And I think this will lead to much more work in this field and make software development automated. Yes, there is, so therefore after this, maybe, we, or maybe after some time, we could be able to automate software development. Maybe, I mean, there are many steps involved in software development, and these language models are getting very, very smarter these days. So therefore, we might use these models rather than hiring software developers, maybe in the future, maybe just 2 3 years. So there is going to be a lot of research. There is going to be a lot of research still, because these models are, yeah, they are pretty good, but they are pretty questionable for huge tasks. So yeah, and for now, I think this is a very, very huge achievement in the field of AI. This paper is actually very good, and I think they have just combined all the previous work that has been in this field of language modeling, and they have grouped it and built this beautiful network. So yeah, I'll be just so ChatDev, our virtual chat powered company for software development, brings together agents from diverse social identities. So we're gonna have a bunch of agents from diverse social identities: chief officers, professional programmers, test engineers, and art designers, of course AIs. Uh, when presented with a preliminary task by a human client, so we're gonna have a human, which is a client, and we're going to have, let's say, a game. So for example, you could put any prompt you want, any task, and what we're going to have to do is, what we are going to do in the model is they're going to, like, yeah, so they're going to try to solve this problem, this task, by grouping a task to different teams, and finally providing us with the source codes and the environment dependencies and also all that. So this might ring some bells to someone. Auto GPT, I mean, you might have heard about Auto GPT. So given a task, right, Auto GPT uses different agents to, you know get to the task, right? There might be different goals or different steps that we have to take in order to have perform the final task. So the Auto GPT will, like, determine all of the basic task, the preliminary task that has to be done, and they will just get to the final task. So that I think that is uh, the main thing that is also happening here. Yeah, auto GPT does that, but here we are going to group them into different teams and agents. So yeah, so this is the abstract. You can read it if you want to. um, yeah, so mm, I'll just read from here, I think somewhere. So in this paper, we present an innovative paradigm that leverages large language models throughout the entire software development process. Right. So we're going to use the language models, and we're going to use a connection of these language models to automate the entire process of software development. So therefore, we could able to automate the whole thing. Um, at the core of this paradigm lies ChatDev model, a virtual chat powered software development company that mirrors the established waterfall model, miraculously dividing the development process into four distinct chronological stages: designing, coding, testing, and documenting. So there are some this chronological stages: designing, first designing the model, or designing the sorry, no, not the model, designing the app, or designing the website, designing the interface, and all that. And then we'll have the coding phase, the coding team, which is going to code the project, will write all the code. And testing phase, we are going to test the application how well it is performing. And documenting stage, right, documenting everything, which is actually quite useful, right? When you are doing software development, you might want to document everything. Maybe you want to update the software code, maybe you want to bring in new models, bring in new features. Then documenting is good, because you can just remember everything. You can just get back to the understanding maybe after a long time after working on that project. um, each stage engages a team of agents such as programmers, code reviewers, and test engineers, fostering collaborative dialogue and facilitating a seamless workflow. The chat chains acts as a facilitator, breaking down each stage into automatic subtasks. This enables dual roles, allowing for proposing and validating solutions through context-aware communication. So yeah, we are going to have bunch of language models that are going to be interacting with each other. Right? For example, the team leader uh, giving instructions to, let's say, the programmer. We will have a separate team leader agent and programmer agent. And also in under 7 minutes. So we're going to complete the entire software development process in mere 7 minutes at the cost of less than $1. Just think of the possibility. Companies are hiring like huge software developers for very high amount of prices. But now, maybe in the future, maybe after 2-3 years or 5 years, we are going to get to a stage where software development, the complete software development, will be done by artificial intelligence in less than 7 minutes. Like I think many papers are going to come in the future that is going to maybe take lesser time. So 7 minutes complete everything with the cost of less than $1. Uh, Maybe for the ChatGPT API, $1. I think it's only $0.2. So yeah. Now it's funny that you could complete the whole software development process in like with a cost of $0.2. So this is the code. You can just check out the code in just a minute, and then yeah, so I'll just read from here. In recent years, language models has achieved significant milestones in the field of natural language processing, large language models, and LLMs have demonstrated impressive performance on a wide range of tasks. Okay, um, and then from this perspective, the Plapper explores an end-to-end software development framework driven by LLMs, encompassing requirements analysis, code development, system testing, and document generation, aiming to provide a unified, efficient, and cost-effective paradigm for software development. Right, directly generating an entire software system using LLMs can result in code hallucination to a certain extent. Right, so let's say you have LLM, a single LLM, a single large language model. So just giving the entire software task to just one LLM, that I mean, you could try it before coming to this approach. So that might create some hallucination. Right, many parts will be forgotten. There won't be any clear structure, and the model will definitely be incomplete. So therefore, there might be bugs and incomplete implementations and missing dependencies. So therefore, it's bad. So these hallucinations is actually because of two reasons: the lack of specificity, yeah, definitely. I mean, I have faced it. When I have when I was using like LLMs when they came, probably last 2 months. I have faced this problem of not writing the specific prompt. Let's say you give a prompt, uh, specificity lacks. Still, when you want to, especially doing software development, when you want the model to do software development, more specificity is needed. You want to stress some things more than other to actually make that happen. And it's actually very bad. I think very bad experience, very hard experience to like prompt engineer. Just change the prompt, engineer the prompt for your specific results. It may take some time, especially if the model is not that powerful. But yeah, especially when you're working with huge projects, this doesn't work. Just giving them in one step. um, and then granular tasks in software development, such as analyzing user client requirements and selecting programming languages, provide guiding thinking. Yeah, so that is not possible. We can have huge analysis on this because LLM is going to do it on like one step. Secondly, the absence of cross examination in decision making process. We are not going to have any cross examinations, code reviews, and feedbacks and bug check-ins and all that. So therefore, it is going to be a very bad thing. So therefore, we are going to build a collaborative structure of a company, let's say, a completely automated company that is going to develop our own application, right? So to address we established a virtual chat powered software technology, chat dev, right? At each phase, chat dev recruits multiple agents with different roles, programmers, reviewers, and testers, to facilitate effective communication and collaboration. Chat dev utilized a proposed chat chain that divides each phase into atomic subtasks. So I think each phase, the designing, coding, testing, and documenting phase will be divided into further subtasks, and each node represents a specific subtask. So we're going to have like multiple nodes in each specific phase, and each node defines a specific subtask that has to be carried out inside the specific phase. This approach ensures that the client requirements are analyzed, creative ideas are generated, more prototype systems are designed and implemented, potential issues are identified and addressed, debug information is explained, appealing graphics are created, and user manuals are generated. Right, so we have a bunch of information about the software development, about the application we are going to generate it, and by guiding the software development process along the chat chain, chat dev delivers a final software to the users, include the source code, dependency, environment specification, and user manuals. So yeah, we're gonna have a bunch of things like that. And then so we propose chat dev, a chat-based software development framework. By merely specifying a task, chat dev sequentially handles designing, coding, testing, and documenting. This new paradigm simplifies software development by unifying main process through language communication, eliminating the need for specialized model at each phase. And we're gonna have chat chain again, decomposing the development process into atomic subtasks, small subtasks, and thus making the thing much more easier. Right. So chat chain. So the coding phase involves the development and review of source code, while testing phase integrates all components into system and utilize feedback messages for interpreter for debugging. So yeah, we're going to have like bunch of we're going to have bunch of nodes inside each phase, and then I think there'll be a route here. So whenever there's a bug in text, we're going to send that to the coding team. We're going to record it. Yeah. So yeah, this is the chain. So we have the CEO, the instructor, is going to give a task, and yeah, and the CTO is going to like provide it with the programmer. The programmer is going to write the code. We don't have a bunch of testers, so programmer to reviewer, programmer to tester, CTO to programmer, and CEO to CPO. Right. So yeah, we don't have a bunch of connections here. I think like a specific chain that is going to propagate together in a chronological order. So let's go to first stage, designing. In designing phase, chat dev receives an initial idea from a human client. This phase involves 3 predefined roles. We're going to have CEO, CPO, and CTO. Just a name. Hope you know it. CEO is the main of the company, head of the company, CPO, product officer, technology officer, and then so we are going to give the roles for each language model. So maybe if when you have like if you have trained language model, you just tell the role of it or role of the language model before using it. That is actually pretty common while you're using it. Let's say for an application language model, you will just specify their role, and then you'll get them to work. So you'll just give the CEO position to a language model. Again, the CEO is also going to be a language model, an AI model, not a human. And then CTO also is going to be a language model. We're going to give the role, and then the role specialization ensures that each agent fulfills their designated functions and contributes effectively to the task-oriented dialogue. The memory stream maintains a comprehensive record of previous dialogues within the chart. So we're also going to have, I think, a neat conversations, just like in ChatGPT. It can remember memory also, the past conversations, enabling agents to make informed decisions. Right. And then the role assignment. Our approach to prompt engine is restricted solely to initialization of role-playing scenarios. So we are also going to take in effect of all the previous conversations also, in order to maintain a better decision making, right? And so we are going to use language models for assigning roles to each. So we don't assign one role for each language model. So we're going the CEO part, the CPO, and CTO part, and then we observe where both parties reach a consensus but do not trigger the pre-event commitment protocol. In such cases, we introduce a self-action mechanism which involves extracting and retrieving memories. To implement mechanism, we enlist a pseudo self as a new questioner and initiate a fresh chart. The pseudo questioner informs the current assent of all the history records from previous dialogues and requires summary of the conclusive information from dialogue. We're going to have, I think, another language model which will just is like a self-reflection mechanism that is going to reflect all the ideas that have been proposed, and that'll be that. The coding phase involves three roles: CTO, program, and art designer. Right, the CTO, so to handle, so based on a software system using Marvin, the program generates codes in responses and extracts the corresponding codes based on markdown format. The designer proposes a user-friendly graphical user face that instead of text-based commands. So then the designer creates visually appealing graphics. So the designer creates graphics, number one. Code management. So we are going to use Python for development, object-oriented programming, for self-contained objects. And then I think there are many details connected to this thought instruction testing. In the testing phase, I think we are going to have the programmer is going to be the programmer is going to get review for this code and also be testing for this code, and then we'll finally have the documentation. After designing, coding, and testing phases, chat dev employs 4 agents: CEO, CPO, and CTO, and programmer, to generate software project documentation. Right? We leverage few shot prompting with in-context examples for document generation. And that's it. I think that's it, right? So the main thing that I want you to take away is that, right, so we are going to develop a system of a system called chat dev, in which we are going to divide the complete software development process into 4 stages: designing, coding, testing, and documentation. So and then we are going to have bunch of agents. We are going to get the LLM and assign different roles for these LLMs. The instruction work will be given to one, and the coding work will be given to one. By this, we could segregate. We could have an organized structure of tasks and the task will be controlled by, I think, another model, which is going to be determine the further tasks that have to be carried out in order to finish the final task, the final thing. And then the programmer is going to code it. We don't have reviewers that is going to review the code and get back to the programmer for my better code writing. And then yeah, so that's it. I think that's it. That's the main thing. In this paper, of course, you are more than welcome to read it all. I mean, I haven't found the time to read everything, but it might be good if you have read everything. Right. So yeah, we would have like bunch of these language models are going to like interact with each other, and very good. And you could even use it. You could even use it for like following these steps in in the terminal. So if you have a terminal, just run these specific functions or commands, and you should also install some libraries, some libraries before running this in your local computer. You have to install Anaconda, and then Git and all that. You could clone this repository. You could just create an environment and just run this, and of course specifying your OpenAI API key, because this everything runs on OpenAI. So that's it for this. So I think that's it for this video. Again, I think AI is getting to great heights. We are seeing great, changes, great inventions in the field. And I think this is one of this is going to trigger some of the most, I think, better papers and better research, better models. So thanks for watching. I'll see you in the next one.